Hello students, in previous lecture we have studied necessity of modulation, types of modulation and amplitude modulation in detail, that is definition of amplitude modulation and its mathematical expression. As the mathematical expression of amplitude modulation is given here, EAM is equals to VC sin omega CT plus MVC by 2 cos omega C minus omega MT minus MVC by 2 cos omega C plus omega MT. Students, you can see here are three terms in this equation of AM signal, and this AM signal contains three terms. First one is carrier, second term is lower sideband, that is LSB, and third one is USB, that is upper sideband. Okay students, and these three terms are represented in terms of amplitude modulated spectrum, and this AM spectrum is also called as frequency domain display. As here is a first term, carrier signal, it has amplitude Vc and frequency omega, or sometimes we'll write instead of omega it is 2 pi f. Okay students, so here fc is written. There is no objection, you can write omega or fc. Okay, for carrier it is fc, for modulating signal it is fm. Okay, now as the second terms represents here LSB, lower side band, it has amplitude MVC by 2, so it is written here, while its frequency fc minus fm. And third term here it is upper side band, so its amplitude is MVC by 2 and frequency fc plus fm. So this plot of a signal amplitude versus frequency is called frequency domain. A spectrum analyzer can display the frequency domain of a signal. So here in this signal, the transmitted information is contained within the side bands, upper sideband and lower sideband. The sideband shows variation of information, that is modulating signal on both sides of carrier from fc minus fm to fc plus fm, that is we can say that bandwidth twice fm. This is the bandwidth of amplitude modulated signal. Most of the power in amplitude modulated signal is in carrier. Okay students, but the useful power is only in side bands, that is upper sideband and lower sideband. So for 100% modulation, only 1/3 of total power is carried by these sidebands. As the modulation index decreases, less power is carried by the sidebands. Okay students, so this indicates decrease in efficiency of amplitude modulated system. This bandwidth is decided by sidebands, and it limits the number of stations that can be used a band of frequencies without interference. Now let us see significance of modulation index. All of you know that modulation index is nothing but the ratio of peak amplitude of modulating signal to the peak amplitude of carrier signal. Okay students, and it is represented in the equation form like this: m is equal to Vm upon Vc. Okay, so the information is present in the variation of carrier amplitude. The modulation index determines the strength and quality of transmitted signal. Here you can see the first, when modulation index is less than 1. This type is called as under modulation. Why? If the modulation index is less than 1, at that time we can say that the term at the denominator is greater than the term at the numerator. Means Vm is less than Vc. Okay students? So, the resultant signal is undistorted, but the strength of signal is weak after detection. And when carrier is modulated to a small degree, the amount of carrier amplitude variation is small and audio signal to be transmitted is not very strong, as the amplitude of modulating signal is less than the carrier amplitude, distortion will not occur. Okay students? So this is called as under modulation when m is less than 1, or we can say that amplitude of modulating signal is less than the amplitude of the carrier signal. Okay. Now in second part, the ideal condition for amplitude modulation is here when amplitude of the carrier, that is Vc, is equal to amplitude of the modulating signal. At that time we can say that when these both are equal, so m is equals to 1, means modulation index is equal to 1. This is called as perfect modulation. This will produce the greatest output at the receiver with no distortion. More information signal is transmitted, thereby producing a stronger, more intelligible signal. For voice signal, only the peaks of the signal can produce 100% modulation. Here, modulation is 100%. After detection, we get maximum strength of audio signal. Okay students? So therefore, in this type, when m is equal to 1 or amplitude of the modulating signal is equal to amplitude of the carrier signal, at that time this m is equal to 1. So this type of modulation is called as perfect modulation, means here m is equal to 1. Now in third part, when m is greater than 1, when this m will be greater than 1, if we observe this equation carefully, if the term at the numerator is greater than term at the denominator, that is, this Vm is greater than Vc, therefore the resultant signal produces distortion. It is also called as over-modulation. And students, you can observe the waveforms here. By observing this waveform, this is a peak amplitude and this is a minimum amplitude. At that time, the amplitude of the modulating signal is greater than that of the amplitude of the carrier signal. Therefore, this is called as a over-modulation. Okay? If the amplitude of modulating voltage is higher than the carrier voltage, at that time this m is greater than 1. So this is called as over-modulation. This will cause severe distortion of the modulated waveform. Therefore, the waveform is flattened near the zero line. You can see the waveform is flattened near the zero line. The negative peaks of the output waveform are clipped. Here, negative peaks are clipped off. Therefore, over-modulation is undesirable. Okay, students? So, this is called as over-modulation because amplitude of the modulating signal is greater than the amplitude of the carrier signal. Students, if you can compare these three waveform carefully, when m is less than 1, then this is a under modulation. If m is equal to 1, this is a perfect modulation, and if m is greater than 1, this is the type of over modulation. Here distortion occurs and negative peaks are clipped off. Okay students, and you can see here is a maximum amplitude. This is V max. Okay, and this is V minimum. In third part, the minimum part of the waveform is clipped off. Therefore, this type of waveform, or when m is greater than 1, this is called as over modulation, or this is undesirable condition. Okay students? Now here from this figure we can say that amplitude of modulating signal is equals to V max minus V minimum upon 2. Here it is a peak amplitude V max and it is minimum called as V minimum, and it is divided by 2. This is a modulating amplitude. In the similar way, carrier amplitude is given here. V max minus V max plus V minimum upon 2. And by using modulation index as M is equal to Vm upon Vc, so we can write this equation. Vm upon Vc is equal to V max minus V minimum upon V max plus V minimum. So this is another equation to find out modulation index in AM signal. Okay students, so this is a peak amplitude and this is a minimum amplitude. From this equation we can find out the modulation index. So from these three diagram we can conclude that M is always less than or equal to 1. At that time we'll get the perfect modulation or under modulation, and this is a desirable condition. But when M is greater than 1, we'll see the distortion and here the negative peaks are clipped off. Therefore this is not allowed or undesirable modulation. Okay students, or this is called as over modulation. This modulation index is also called as modulation factor or degree of modulation. And if we have to find out percentage of modulation index, then modulation index multiplied by 100 will get the percentage of modulation. Okay students, now some important terms related in amplitude modulation to solve different type of problems. Okay students, and this is nothing but revision for amplitude modulation. First, carrier signal. As all of you know that electromagnetic wave equation is given by Vc sin omega ct. Here Vc is nothing but amplitude of carrier signal, while omega c or will replace here instead of omega 2 pi fc. This is the frequency of carrier signal. Okay students, now in case of modulating signal, Vm is equal to Vm sin omega mt or Vm sin 2 pi fmt. Here Vm is the amplitude of modulating signal, while omega m is equal to 2 pi fm. This is the frequency of modulating signal. As all of you know that this frequency domain or AM spectrum consists of two side bands, lower side band and upper side band. So LSB, that is lower side band, it is given in terms of frequency FUSB is equal to FC plus FM. Here upper side band gives the addition of frequency of carrier and frequency of modulating signal. But in case of lower side band, here is a frequency of carrier, frequency of modulating is subtracted from the frequency of carrier. So this FLSB is equals to FC minus FM. Then modulation index. Here modulation index is equal to amplitude of modulating signal to the amplitude of carrier signal, that is Vm upon Vc, or Ma is equals to Ec max minus Ec minimum upon Ec max plus Ec minimum, or sometimes instead of E, here V is written. Okay students, bandwidth is equals to FUSB minus FLSB, that is upper sideband frequency minus lower sideband frequency, and given by FC plus FM minus FC plus FM, and this is twice FM. So bandwidth in AM signal is given by twice FM. At last, we know that from this frequency spectrum of amplitude modulated signal, amplitude of the carrier is Vc, frequency is Fc, and here amplitude of sideband is given here. It is same for LSB and USB, that is MVC by 2. So amplitude of sideband is given by MVC by 2. Okay students, I think all of you got the clear idea about different type of terms and their related formulas. This will be helpful to you for solving different type of problem related to AM signal. As recently we have revised these different type of terms and their formulas, now let us see some problems on amplitude modulation. Okay students, now first problem, if in an AM system EM is equals to 25 cos 3000 pi t and EC is equal to 50 cos 16 lakh pi t, find sideband frequencies and their amplitudes. Now students, all of you know that amplitude of the carrier signal is always greater than that of the amplitude of the modulating signal, and frequency also maximum. So first we have to write down the given things. Solution. Now first you have to write down the equation EM. Student, tell me, this equation is given for modulating signal. So this is 25 cos 3000 pi t. Okay, this is equation for modulating signal. From this equation you can write this 25 is nothing but the amplitude of modulating signal, and this is 25. Okay, now this 3000 is nothing but 2 pi fm is equal to 3000. As you know that the equation EM is equal to EM cos 2 pi fm t. Okay, from this equation this is 2 pi fm 3000. Okay, but we have to find out only fm, so therefore fm is equal to 3000 divided by 2. So we'll get value of fm is 1500 hertz. Okay students, now this is amplitude of modulating signal, frequency of modulating signal. What about this second equation? This is the equation for carrier. So it is given in terms of EC 50 cos 16 lakh pi t, and we know that EC is equal to EC cos 2 pi fct. Okay, so here EC is equal to how? Yes, it is 50 volt. Now from this equation this 16 lakh is equals to twice fc, so it is Fc is equal to this given term, that is 16 lakh divided by 2. So we'll get 800 kilohertz. Okay students, here divide by 2 to this 16 lakh will get 8 lakh, and this 8 lakh is converted into 800 kilohertz in this way. Okay students, so don't confuse. So this is Fc. What we have to find out? Find sideband frequencies and their amplitude. First we'll find the sideband frequencies, and we know the formula. For here, formula for upper sideband is here USB upper sideband frequency F USB is equal to Fc plus Fm. For F LSB, that is Fc minus Fm. So this is formula for lower sideband LSB. Okay student, so by using this formula we can write here Fc plus Fm. Fc is nothing but 800. As this is 800 kilohertz, we can convert this Fm. Instead of writing 1500 hertz, it is 1.5 kilohertz. Okay, now 800 plus 1.5, okay, and it is in terms of kilohertz. So we'll write here 801.5 kilohertz. So the frequency of upper sideband is 801.5 kilohertz. Now what about F LSB? Lower sideband frequency is given here, Fc minus Fm, and this Fc minus Fm is 800 minus 1.5, and it is in terms of kilohertz. So we'll write here this is nothing but LSB lower sideband frequency is 798.5 kilohertz, and it is always less than that of USB. Okay students, now we have to find out amplitude of sideband. So amplitude of sideband can be find out with the help of the formula modulation index, and this is modulation index is the amplitude of modulating to the amplitude of carrier signal, and as we know that amplitude of modulating is 25 volt while amplitude of carrier signal is 50 volt. Okay, so by finding but M is equals to Vm upon Vc, or we'll write Em upon Ec. Okay student, you can write any term, there is no objection. Then Em is 25 and Ec is 50. So we'll get 0.5. Students, remember that this modulation index has no unit because here is a ratio. Therefore, modulation index is 0.5. Okay. Now, we have to find out amplitude of sidebands. What we have to find out? Yes, amplitude of sidebands is equals to M EC by 2. Okay, so it is given here M 0.5, EC it is 50 upon 2. So finally amplitude of sideband is equal to 12.5 volt. Okay, so students, in this way you can find out the different terms with the help of these formulas. Okay, carrier signal, modulating signal, USB, LSB, modulation index, bandwidth, amplitude of sidebands. Okay students, so first you have to read the problem carefully. Here you have to read this problem carefully. First you have to write down the equation, then find out the terms which are given in the problem and write down the terms which we have to find out. Here we have to find out sideband frequencies and their amplitude. Okay student, then you decide which formula we have to use. Okay, in this way you can solve any problem. Students, this is the second problem. A carrier wave of frequency 1810 kHz and peak value is 60 volt is amplitude modulated by 2 kHz audio wave of amplitude 30 volt. Determine modulation index and bandwidth. Students, in this problem directly you have given the frequency of carrier and frequency of modulating signal. So we'll write here FM is 2 kHz. Okay, then FC is 1810 kHz. Peak voltage of the carrier is nothing but EC, that is 60 volt. Okay, and EM is equals to 30 volt. What you have to find out? You have to find out modulation index and bandwidth. Okay, you have to find out modulation index and bandwidth of AM signal. Now all of you know that the formula to calculate the modulation index is nothing but the ratio of amplitude of the modulating signal to the amplitude of the carrier signal, that is EM upon EC. So EM is 30 and EC is 60. So the answer is 0.5. So we can write here modulation index is 0.5. Okay students. Now second, you have to find out bandwidth. For bandwidth, first we have to find out the frequency of upper sideband and frequency of lower sideband. Therefore F USB is equals to FC plus FM, and that is equals to FC 1810 plus 2 into 10 raised to 3, because both are given here in kilohertz. Therefore we'll write here 1812 kilohertz. It is a frequency of FUSB. Now frequency of lower sideband is FLSB is equals to FC minus FM. Therefore 1810 minus 2 into 10 raised to 3, this is equals to 1808 kilohertz. So here this is a frequency of upper sideband and this is a frequency of lower sideband. Now bandwidth is given by bandwidth is equals to FUSB minus FLSB. means we have to subtract lower sideband frequency from upper sideband frequency. So we'll write here 1812 minus 1808. Therefore we'll get 4 kilohertz. So this is a bandwidth of the given signal. So bandwidth is equals to 4 kilohertz, and this is a final answer. In this way you can solve different types of problems. Okay students? Now this is assignment number 3 for this chapter number 5, paper 1. Question first. Explain the significance of modulation index in AM. This question carries 3 marks. Then question number 2. In AM, carrier voltage increases to 150 volt and reduces to 30 volt due to modulating signal. Calculate modulation index. This question carries 3 marks. Question number 3. If an AM system uses EM is equals to 60 sin 3000 pi t and EC is equals to 120 sin 60,000 pi t, find audio frequency, carrier frequency and modulation index. Okay students, this question number 3 carries 4 marks. So in this way, today we have completed significance of modulation index and some problems on amplitude modulation. Okay students? In next lecture, we'll see different type of problems on AM and the new topic frequency modulation in detail. Okay students? So this is enough for today's lecture. We'll see in next lecture. Thank you.